Let's take a look at the normal distribution. Let's say I went out and I measured 100 men to see how tall they were. And then I made a histogram of their heights. Remember what a histogram looks like? Where we would arrange the data into classes and then make a chart. It might look something like this. Along the horizontal axis would be people's heights. These are the heights of men in inches. And then we would draw bars indicating, and the height of the bar would show you how many men fall into each height category. There are probably a lot of men between 5'8" and 5'10". So that bar, pretty tall. Also between 5'10" and 6 feet. A lot of men in that category. Not quite so many men over 6 feet tall. That bar is going to be shorter. 6'2" to 6'4", much smaller. 6'4" to 6'6", smaller again. Over here, there aren't that many men here, and very few men under 5 feet tall. So this histogram is bell-shaped. Remember that from a few chapters back? A bell-shaped histogram. Now, what if instead of 100 men, I went out and measured the heights of 10,000 men? And instead of using bars every 2 inches of height, I used lots and lots and lots of bars. Instead of looking all boxy like that, it might look more like this. Now we're going to have lots and lots of bars. The more classes that I use, the more people I measure, the smoother this looks. Ultimately, it's going to look like a nice, smooth curve. This is the normal distribution. It is symmetric. And it's shaped like a bell. Now, there's one thing you should realize about the normal distribution. In ordinary English, the word normal has a kind of judgment attached to it. Like it's good to be normal and it's bad to not be normal. That's not what the normal distribution is about. When you say that something is normally distributed, all that means is that values towards the middle, towards the norm, the average, tend to crop up more often. If you say men's heights are normally distributed, you mean there are more medium-sized men out there than there are very tall men or very short men. It turns out that a lot of variables are normally distributed or pretty close to it. People's heights, people's weights, people's shoe sizes. If you don't want to use people, the weights of 30-day-old rats are probably normally distributed. The length of time that it takes people to walk a mile might be normally distributed. There are also some things which are not normally distributed. People's incomes are not normally distributed. People's incomes might look more like this. Got a whole bunch of people who are working class, middle class, and then you have this very large tail here. very long tail. Because there are a few people out there who make a lot more money than anybody else. And the tail would keep going right out of this room. So income, not normally distributed. So why is this normal distribution so exciting? Because it's powerful. If you know that a variable is normally distributed and you know its mean and standard deviation, you know everything about it. Weird? Let's see.